All right, welcome to another exciting episode of Advanced Level Chemistry. Here we are at Spain Park. It is Monday, March the 3rd. We are into March. That's awesome. Last week of the 9 weeks, which means we're almost there. We've got one more to go, and the last one flies. So, today we're going to work on total net ionic equations. You need to ask questions. We're going to have a worksheet to go through. Your labs are due tomorrow. Your labs have total and net ionic equations as the last part, which is why I extended the deadline till tomorrow for that. Tomorrow we're going to do, like I said, an activity that introduces the next unit, which obviously is not going to be on the test, but you're going to have the test on Wednesday. Okay, so today needs to be a very productive day in terms of doing the work. Now, in order for us to do that, I have a worksheet for you. Okay, and I have an activity series. Here's your own activity series. 2, 3, 4. Go ahead and just pause that video right now. Pause it. All right, so when we're doing a total and net ionic equation, the whole goal is to represent how the substances are actually in solution. So again, this is a deep question. What are ionic compounds composed of? Ions. So when they dissolve, how do they dissolve? As ions. So we're going to represent them how they are in solution, not just in our main equation. So in our lab, we did magnesium solid plus hydrochloric acid, HCl, which was aqueous. And what did that make?
Magnesium chloride and hydrogen gas.
Okay, magnesium chloride, MgCl, but what do we always have to do first?
Balance the charge.
Balance the charge. What's the charge going to be on magnesium?
+2.
+2 or 2 plus. And what's the charge always on chloride?
-1.
-1, so the formula is going to be MgCl2. Okay, plus, and I heard somebody say hydrogen gas, but hydrogen is always going to be H2. Okay, and that's a gas. Now we do need to know what state this was. Now in the lab we could just observe the magnesium disappeared. But if I'm going to go and I need to know, I have water here, so the state, I can look at chloride up there on the chart, okay? And it says most chlorides are soluble. But silver, lead, mercury, and thallium, Tl, they're insoluble. Well, is magnesium any one of those four? That means it falls into the most cations category, meaning it's going to be aqueous. And then the last thing we have to do is balance it. How do we balance this? By putting a 2. Okay, so we know that this is a single replacement reaction. Okay, single replacement. Now, but how is it actually in solution? So to represent our total ionic equation, now this word right there is kind of a clue. Ionic. So it's going to break up into ions. Only aqueous things break up into ions. Only things that are electrolytes break up into ions. Electrolytes are your strong acids, bases, and salts. Well, what is this? HCl is what type of compound?
Salt.
No. How do I know? It's hydrogens at the beginning, so I know it's an acid. It's one of our 6 strong acids. It's going to dissociate. Now, can a solid break up into anything? No. Plus, only aqueous dissociates. So we're going to keep magnesium as a solid, but the acid is actually going to break up. What are my 2 ions making up HCl? Hydrogen and chloride. Now again, they're ions, so by definition, what are ions? Charged particles. So it's not going to break up into H and Cl. It's going to break up into H plus and Cl minus. But since there's 2 here, how many H pluses am I going to get? So it's going to get 2 H pluses. And if it's aqueous here, it's aqueous down here. And 2 Cl minuses, aqueous. So in other words, when we have hydrochloric acid, it's not HCl molecules floating around, it's H pluses and Cl minuses floating around. The water causes them to ionize, to break apart from one another. So we're representing how it actually is in the solution. It's not going to be together like this. It's actually going to be apart. This surrounded by water, this surrounded by water. But the water gives it mobility then so things can react. But if they're stuck together, they can't react. So now, this is MgCl2, so it's an aqueous ionic. So what are my two ions? What's it going to break up? What's it going to dissociate into?
Mg plus.
Mg2 plus. Okay, now here's the hardest part. What's the ion here? Is it a Cl2 minus ion? No, because remember, it's going to be Mg2 plus, but it's attached to a Cl minus and a Cl minus. So when it goes into water, it's going to break. Are those Cl minuses going to bond together? No. The 2 here means it's bonded together, so what am I going to get? 2 Cl minuses. Because the ion is a Cl minus ion. It's not a Cl2 ion. It's a Cl minus. All of your halogens, F minus, Cl minus, Br minus, I minus. Now you might get 2 of them, you might get 3 of them, you might get 4 of them, but they're not going to be all bonded together. The subscript would indicate they're bonded together. Here it's a subscript because it's bonded to the magnesium. But when it goes into water, they're going to all break apart and we're going to get 2 Cl minus ions. Okay? That's the part that gives everybody a problem. Knowing when the subscript stays and when it breaks apart. And then lastly, what are we going to get? Okay? Now, is the hydrogen staying in the water? What did we observe when we put the magnesium into the acid? Bubble, right? Bubbles means it's coming up out of solution, then we lit the match, whoop, and made the test tube bark, right? Only aqueous break apart. Okay? Everybody say that together. Only aqueous breaks apart. Solid, liquid, and gas are always going to stay together. So the gas is bubbling up out of the solution, so it's not staying in the solution, so it's not going to be 2H. It's going to stay as H2 gas bubbling up out of the solution. Only aqueous dissociate. Only aqueous break apart. You keep the solid, liquid, and gas always stays together. Okay? That's essential. Solid, liquid, and gas always stay together. Solid, liquid, and gas always stay together. That was for Hilti, just for emphasis. Okay. Hydrogen gas, yeah, you got to put that somewhere. All right, so now I have my total. So everything, this is all going to be floating around. So the magnesium solid goes in, the H and the plus are floating around, but the magnesium changes from, what's the charge on magnesium here? 0. Okay, now you don't have to write it, but I'm just putting it there for emphasis. So it's going from 0 to plus 2. What happens there? How does it go from 0 to plus 2? Loses 2 electrons. What's the hydrogen? What's the charge on hydrogen over here? 0, right? Because that's its element in its natural state. It's 0. So what happened to the hydrogen? It went from plus, each hydrogen is plus, to 0. So what happened to it? How did it do that? Gained electrons. So this loss, this gain, what did the chloride do? Nothing, right? It's just there. What do we call that? That's my spectator ion. This and this. So now, what's my net? What really happened then? The net ionic equation. Without the spectator, what do I get? Magnesium 2 plus goes to plus H2 gas. So the reality is that you put whoops, that's not supposed to be there. That's not supposed to be there. Totally did it wrong. That came to there. Okay? Sorry.
On the right too, correct?
No, the right's right. Okay? So what did the magnesium do? It went from a solid that's not soluble in water to an Mg2 plus that's now dissolved in the water. The hydrogen went from being dissolved in the water to becoming a hydrogen gas bubbling up out of the water. What's the real reaction? Well, magnesium lost 2 electrons. Each hydrogen gained 1 for a total of 2, gaining 2 electrons. It's the transfer of electrons. Magnesium got oxidized, hydrogen got reduced, and the chloride just was there. So the reality is it doesn't really matter what the anion is. So when you see H+, that really means any acid. You can put magnesium into any acid. HNO3, H2SO4, acetic acid, HC2H3O2. Doesn't matter what the anion is, it's just a spectator ion. It's there just to balance charge. It's there because it's there, but it doesn't really do anything. It's the magnesium reacting with the H+. Now, is magnesium above hydrogen on the activity series? Yeah. So you check that to make sure that reaction occurs. So we know the net tells me what's really going on. Magnesium's getting oxidized, hydrogen's getting reduced. The Cl- is not doing anything. Okay? All right, so let's look at another one. We did copper solid plus silver nitrate. Okay, this was I did as a demo for you. And it went and we said, now remember, copper can be +1 or +2. But we chose +2. Why did we choose +2? It's the bold, it's the more common one. So what am I going to get if I choose copper +2? What product? Copper what? What's the copper nitrate? So it's going to be copper 2+, and then the nitrate is NO3-. So what's the formula going to be? Okay, got to put it in parentheses and a 2, plus, what's my other product?
AG.
Just AG. And again, remember, we saw the silver precipitate out. That formed a solid on the bottom. So when it's precipitating out as a solid, that means that it's neutral, it's silver metal. This was copper solid that we put in. Okay? Now I need to balance this. How do I balance it? I need a 2 there and a 2 there. Now I just have to decide, was this soluble or not? Well, what do we know about all nitrates?
They all are soluble.
They're always soluble. So that means that this would be aqueous. So take a minute and see now if you can just, on the back side of that sheet that I just gave to you, there's some space at the bottom. I would put both of these on there, but see if you can do this one, do a total and net ionic equation for this. Okay? You go ahead and pause the video too while you're working on that. First off, this is single replacement, so how do I know something's going to happen? What do I have to look at for single replacement to know something's going to happen?
Activity series.
I have to look at the activity series. Is copper higher up than silver on the activity series? Okay? They're both near the bottom, but yes, copper is above silver. So that means it will replace the replacement of a metal by a more active metal. So my total here, copper, there's nothing it can do. It's just copper solid. But silver nitrate, what are my 2 ions? I'm going to get silver and nitrate ions, right? So I'm going to get, I heard you saying 2 Ag pluses. And since it's aqueous here, we're just describing how it is in the water, so it's not going to change states. Plus, how many nitrates am I going to get? 2 nitrates. Okay? So in other words, when I look at a bottle of silver nitrate, I don't have silver nitrate molecules floating around in here. I got silver ions surrounded by water, and I got nitrate ions surrounded by water, and they're all floating around. The water breaks them apart, so now they're free to interchange and react and mingle with the other chemicals. Okay? So now I'm going to get, since this is aqueous, I'm going to get Cu2 plus aqueous plus what? 2 nitrates. Again, I'm going to get 2 of the nitrate ions. Now I don't need a parenthesis when I put it up here, because just by saying 2 NO3-, that 2 automatically distributes. Now if you put a parenthesis, it's probably not going to be the end of the world, but you don't need the parenthesis now because the 2 here. There's no way for me to put a 2 without a parenthesis here. Okay? And then what's my other product? 2 Ag, And whenever it's a solid metal, it's always going to be a zero charge. Okay? So what's my spectator ions? Just the NO3s, right? And it's got to be exactly the same on both sides. So, and I didn't put my AQ down here. But it's going to be exactly the same. Now somebody asked me in the other class, do I have to put the aqueous and the solids on these? This is the one equation you're going to have to put it. Now, will I give it to you here? Most likely yes, in this respect. Okay?
So the only reason the silvers don't cancel out is because one is aqueous and one is solid.
And one's a positive and one's neutral. Because the reality is the whole reaction, the net reaction, is copper solid goes to 2Ag plus aqueous, and it's going to end up making Cu2 plus aqueous plus 2Ag solids. So what's the real reaction? What's taking place? When we put the copper metal, the copper into the silver nitrate, and we see all of this, okay? This whole reaction taking place. What's really happening here? Here's the silver precipitated out. We got a blue solution. What really is the net result of what happened? What is?
Copper.
The copper is getting oxidized. It's going from 0 to +2, and the silver is getting reduced. So the whole reaction is silver stealing the electrons from the copper. The nitrate's just there. Spectator. Not doing anything. Okay? So only aqueous break apart. We just look at the ions. The tricky part is when does the subscript become the coefficient? So let's look at a double replacement reaction now. So turn that worksheet over. Let's just look at number 1, and then I'm going to let you do the rest of them on your own. Okay, so we're looking up here, and we're going to assume, it doesn't say it on this particular one, but it just says the ionic equation. We're going to assume this is the total ionic equation. That means just you include everything. So when we look at this, what is the NaCl going to break up into? 2Na plus 2Cl minus. Aqueous. Right? You got NaCl, but there's a 2, so I'm going to get 2 NAs and I'm going to get 2 Cls. And these are ionic compounds, so it's really Na plus and Cl minus. What's the lead nitrate going to break up into? Pb plus 2, or 2 plus 2 NO3 minuses. Okay? Now, what about the PbCl2? Why? Because it's a solid. It stays together. What's the only thing that breaks apart? Aqueous. Solid, liquid, and gas stay together. You think I'm trying to make a point? Okay? I just went to a class and they said if you want somebody to really understand what you're trying to get across, you got to say it 7 times. I think for us it's more like 10 to 14. Okay? PbCl2 solid plus, what's the last product going to break up into? 2 Na pluses plus 2 NO3 minus aqueous. So now, what are my spectator ions? The 2 Na pluses and 2 NO3 minuses. Y'all, whatever this aqueous product is, those are going to be your spectator ions. So, I mean, you can really get to the net ionic when I just say, okay, here's my solid, so it's going to be Pb2 plus, and my 2 Cl minuses are going to come together to make Pb2Cl2. But we write the whole thing out, so my net is going to be 2 Cl minuses plus Pb2 plus, that's a lousy B, gonna go PbCl2 solid. So my spectator ions are what? 2Na plus and 2NO3 minus. Are you kind of seeing the point here? Okay, so now let's just practice. Okay, and then you can call me over. We can double check as you kind of go through. Again, this is not going to be assigned as homework, but it's going to be practice. You're going to have 2 of these on the test on Wednesday. Okay, and your last question on your lab that's due tomorrow, you have to write out the total and net ionic equations for 2 of the reactions. Okay, so however you want to use your time, you got another 20 minutes or so. Let's make sure we know how to do these. Okay, ask questions, call me over, talk to one another, work it out. Okay, go ahead and pause the video.
Pause it?
Pause it, yeah, in case I